The Claas Harserwinkel plant, Germany, is the largest and most modern plant for the production of grain harvesters in Europe. Large-size Claas Lection combine harvesters are produced here. Metalworking shop. It all starts in the sheet metal shop, where an automatic conveyor puts steel sheets under a lift-master press. The parts of the future Claas combine must be given a three-dimensional shape. Smaller parts are stamped using semi-automatic presses of different capacities and widths of the working area. The robot manipulator easily lifts parts, weighing up to 160 kilograms onto the press. Parts of a complex configuration are cut with precision to the fraction of a millimeter on a robotic complex with a plasma cutter, which burns 2.5 centimeters of steel per millisecond. Some of them are already ready for painting and subsequent assembly, while others are still only components of large components of the combine and are moving to the next important technological stage of production, welding. In the welding workshop, several welding technologies are used at different stations at once, which make it possible to manufacture the combine frame, threshing separating unit, grain hopper, and other parts of the future combined. In the manufacture of such an important element of the combine as the frame, MAG technology is used, semi-automatic welding in a safe gas environment. The welding equipment used at the factory has advanced technologies, ensures the best quality of welds, and minimizes the influence of the human factor. A feature of the production of large parts of Claas combines is the use of auxiliary welding equipment. This equipment ensures the exact geometry of nodes and parts during welding and also allows reconfiguration in just 2 to 3 minutes. The quality of welded points and seams is checked both visually by the welder himself and by specialists of the quality department using laboratory equipment. Here, next to the assessment of the welding quality, the geometric parameters of the nodes are checked for compliance with the drawing. After welding, the assemblies are sent to the parts loading station, where they are automatically fed to the paint shop using a unique system of sealing conveyors. To ensure that the harvester parts do not corrode and the harvester lasts for decades, metal components undergo step-by-step processing in 13 baths. The fully automated process allows you to control the processing time, temperature, and circulation in each bath. According to Claas technology, the surface to be painted should first be degreased, washed, applied zinc phosphate, which ensures improved adhesion between the metal and the primer, and then, after the next wash, apply cataphoresis. Then the part is sent to the oven, where the polymerization process, in other words drying, occurs. This coating provides good anti-corrosion resistance, as it completely protects metal surface from contact with the atmosphere. In this case, the thickness of the cataphoresis soil should be in the range of 25 microns. This parameter is strictly controlled, and at the exit of the part from the painting shop, final quality control of the coating is carried out after drying. The part is sent to the assembly shop. The final assembly line. Here, the combine gets a body, a hopper, a cabin, and an engine. During installation in the assembly shop, workers install over 4,000 different parts. The logistics department plays a big role at this stage. His task is to ensure that all the necessary materials and components are always at hand, and the assembly line does not stop. The harvester assembly process begins with the installation of the frame. Large components and mechanisms are added to it step by step at each post, which are collected on additional transverse conveyors located on the sides of the main line. Next, a set of power plants and straw walkers is installed, in which the grain is separated from the straw. It is a complete module that cleans the grain from chaff and dirt waste. At maximum plant load, the assembly conveyor provides an output of 1 combine per hour. The engine is the heart of the class combine. Here begins with the connection of the chassis frame with a grain pan. At the next station, a grain tank with a capacity of 6,000 litres is placed on the combine and it is screwed to the frame. A special tube is screwed to the grain tank. Its task is to empty the grain tank, inside which there is a sensor signalling its filling with an external flash lamp and a control lamp inside the cabin. At this stage, the harvester moves along the main assembly line thanks to a pneumatically driven transport system. The elements of the combine include the supporting frame, the thresher housing, the grain tank, the conveyors housing. Then a cabin and a grain bin are mounted to the combine. Professional modern equipment allows you to mount such a large unit as a cabin in just one person. The next assembly operation takes place, joining the harvester's unloading auger. At the front, there is an inclined conveyor which transports the cut grain to the threshing machine. one of the final posts, diesel oil, fuel, brake and coolant fluids are supplied to the combine through hydraulic tubes and hoses. Each combine coming off the line undergoes its first running and adjustment here in the test box, where all units and the entire hydraulic and electronic system are tested. And if even minor errors were made during the production process, they are definitely eliminated. Before the combine is delivered to the customer, from the moment the combines are set up in the test box, the assembly process reaches the finish line. All that remains is to install the cladding parts. The side covers are screwed on both sides of the combine, and they rotate on hinges to allow the operator easy access to the engine and drive units. And install the wheels. The combine is ready. After final inspection, the new SLA's combine will be sent to the customer.